So once again, good morning all. So in today's class, we are discussing with a doubly linked list. So in doubly linked list in yesterday's class, we have gone with a insert operations. So insert at the beginning and insert at a specific location. We have gone with two types of insertions, insert at the beginning and insert at the location, that it can be in after the first node, after the second node, or after the third node. So that we have seen in the yesterday's class. So in today's class we are going with deletion operation. So what you are going to perform if you are deleting. So deleting the node, there are two cases. So one is the deleting at the beginning and the other one is deleting at the end. So keep that one in your mind, how many operations you can do. So you can perform deletion at the beginning and at the end. You can't perform at a middle location. So you can, if you can't delete the particular one in the middle. Okay. So in today's class, we are going with deletion at the beginning and at the end. Okay, so now you come for the delete at the beginning. Okay, so keep in your mind the node what you are going to delete. Here we consider it as temp. Okay, so both in deletion at the beginning and deletion at the end, so you are considering it as temp. Okay, so what is the node to be deleted? It is called as a temp node. Okay, so now you come for the delete beginning function. So under delete beginning, first you take a node called temp. Okay, so node called temp and temp is equal to h. Okay, so this one you can take it. So node temp and then you assign temp is equal to h. Okay, so that means h is the node which is the first node. Okay, so if temp then next is equal to null. Okay, so temp is equal to h means, so what is the meaning of h? Can anybody tell? It is the only node that we call it as head node. Keep in your mind. So temp is equal to h means it is the only node you are having. So and that one we call it as head. Okay. If temp, so now temp is the only node. So how many fields the temp will have? Do anybody can answer? So how many fields the temp will have? In doubly linked list, we are having a temp. Okay. So how many fields the temp will have? The first node, we call it as head node. That's why we have taken it as H. Okay. So if you are deleting at the beginning, that H should be marked as temp, because temp is the node which you are going to delete. Okay. So can you tell how many fields the node will have? How many fields a node have in doubly linked list? Anybody can answer? One node will have how many fields? Two. I'm not asking in singly linked list. I'm going for fields in doubly linked list. Is it two? How many fields a node will have in the doubly linked list? Go for any diagram. You see here in doubly linked list, this one is called as a node. Okay, so node is having first field, second field, and third field. Okay, so first field we call it as first node, we call it as head. Okay, but first field we call it as previous, second field we call it as data, and third field we call it as next pointer. So first field is the previous pointer, and second field is the data, that is the element what you give, and third field is the next pointer. So keep in your mind the how many fields a node will have. We have three fields here. Okay, so now you come for the insertion, this deletion. Okay, so under deletion, now you see if you have only one node, Okay, if you have only one node, so I've already told you, you have three fields. So one is that temp.prev. So three fields. So three fields are, so one is temp.prev, next one is temp.data, and third one is temp.next pointer. So these are the three fields you have. One is temp.prev, that is the previous pointer. Next is the temp.data, so that is the data what you give, and temp.next, that is the next pointer. Okay, so if temp then next is equal to null, that means so next will point to what? It will point to the next node. Okay, but if you are having it as null, okay, so if it is having null means, so what happens if the temp then next is null means what will happen? So this will happen only when you have only one node. When you have only one node, so the temp then next will be always null. So at that time you are going for a free. Okay, free of temp will delete then delete a node. Okay, so then mark h is equal to null. Okay, so as you there is only one node, so at that time you have temp then next is equal to null. If you have the second one, if you have this second node, what you will give? Temp then next is equal to node 2. In place of null, you will be giving node 2. But if you are having only one node, so temp then next will be pointing to null. Okay, at that time you are deleting the null and mark h is equal to null, because h means what? It is the head. So head, as there is only one node was there and you have deleted that particular one node, and that's why you tell head is equal to null. Okay, if it is not only one node, if there it is not only one node, what you will do? You will point h is equal to h then next. Okay, if it is only one node, this will happen. So else part we have when two two or more nodes present. When two or more nodes are present, so what you will do? So you will go for h is equal to h then next. Understand this one? When there is only one node, you delete a node and make head is equal to null. If you are having more than two nodes, so what you will do? You mark h is equal to h then next. Okay, so deleting %d temp then data, then you perform free of temp. So keep it this one in your mind. If you are deleting, so both the next as well as previous pointers should be removed. So if you, now you come for this diagram, if you are deleting this node, so you have to make the head node as node B, and you have to make the previous pointer to make it null. Okay, so you have to make head node to node B, and you have to make node B dot previous to null, because node B will act as first node now if you delete node A. Okay, so that is the deletion at the beginning. Okay, so once you are deleting temp then data, and you will give freeze of temp. Okay, so when two or more nodes are present, so first you make the head is equal to head then next. Head then next means you are marking, you are removing the next field. Okay, and next you are removing the temp then data. Okay, so this is the case for delete at the beginning. So now you come for delete at the end. So if you are deleting at the end, so now you have to go with the two concepts. So last node, last but one node. These two are very important. So go for this diagram. I will tell you, if you are deleting the last node, which is the last node here? Can anybody can tell which is the last node? In dia, which is the last node? Can anybody can tell which is the last node? last node D. Okay, last but one node. Last but one node. Last but one node is C. Okay, good. So now if you are deleting the last node, what are the things you should make? If you are deleting the last node, what are the things to be make? Now you are deleting node D. Okay, so what should be done? Can anybody can tell? Now you are deleting the node D. Okay, if you want to delete the node D, so what should be the node D? Node, this one we call it as temp, and this one temp 1, and this one we call it as temp 2. Okay, you have to make null. Which one you will make null? So this one I am going to consider, see it here. This one I am going to consider it as temp 1, and this one I am going to consider it as temp 2. And now you are deleting temp 1. Okay, so keep this one in your mind. So no, last node D we consider it as temp 1, and node C we consider it as temp 2. Okay, so then now you are going to delete. So how you delete? So that we shall see it here. So now you see, so just I have consider it as node temp. Okay, so temp is equal to h. So it is the same case. Okay, so what we have here, it is same. Temp is equal to head. Okay, if temp then next double equals null, the same. If it is only one case, what you will do? So if there is only one node free of temp and it is equal to null, this is the same case what you follow here. No temp will be same. Temp is equal to h, temp is equal to h, same. Next temp then next is equal to null. Here also temp then next is equal to null. So this will happen only when you have only one node in the list. When you have only one node in the list, what you will do? Free of temp, h is equal to null. This is the case. Okay. Suppose if there are more than one node, so this you will get when you have more than one node. When you have more than one node, what should be done? So keep in your mind, I am taking two nodes. Okay, so make temp 1 is the node to be deleted and temp 2 is the previous node. So keep in your mind here, I am telling here, so temp 1 is equal to D. Okay, just an example, and temp 2 is equal to C. So which one you are deleting? You are deleting node temp 1, that is node D. Okay. So what should be done? First you have to remove. Okay. So temp 1 then previous should point to temp 2. So temp 1 then previous is pointing to where? Temp 2. So keep in your mind. So I am telling D then previous. So what is D then previous? D then previous is, this one is temp 1, this one is temp 2, no D. This one is temp 1, then previous is pointing to where? It is pointing to temp 2. Okay. So next you come here. Next you make temp 2, then next is equal to null. So which is temp 2 here? So temp 2 is node C. Node C then next should be marked as null. So keep in your mind, you have to remove this 2. So first you take temp 1 then previous is equal to temp 2. Okay. So that means temp 2 is equal to temp 1 then previous. Then you are, if you are deleting this one, so this will be the last node. So at that time, temp 2 then next should be marked as null. So that's why we are taking it as temp 2 then next is equal to null, and finally you are deleting temp 1 then data and you are free. Okay, so are you understanding the, have you understood this one? Have you understood? So have you understood this particular concept? So before that, I'm already telling you again and again. So first you are going with a deletion. So if you are deleting this one, so what you will do? So first you will mark this one as node temp1 and this one as temp2. So temp1 is to be deleted. So first you what you will make? So first you remove this particular connection. So how to remove this particular connection? That you mark it as temp2 is equal to temp1 dot prev. Then you mark temp2 dot next is equal to null. Then you delete. So how you delete? By using the free operation. So here you see your free of temp1 will remove the node d. Okay. So this particular will remove the node d in our example. Okay. So this is the case you have to do for deleting at the end. Okay. So now you come for the entire program now. So this is the delete operation you have to take. So this is the complete double linked list program. So insert at the beginning, insert at the middle, and now you go for the display and then you come for the delete. So deleting specified node is also given here. So totally you have to go with the 3 cases. So till now under delete you have gone with the 2 cases. One is deletion at beginning and deletion at end. So now you come for the third case. So third case is deletion at the specified. So keep this one in your mind. So deleting at the specific node. So it can be in the middle. So how you perform if you are deleting the middle one? So if you are deleting the middle one, so first you go with a node q is equal to star s. So it is star q is equal to star s. So what the star s means? So star s means it will be the start node. Okay. So now if q not equal to null. Okay. So if q then data double equals m, that means node to be deleted is found. Okay. So if this is the case, if the node to be deleted is the first node, if the node to be deleted is a first node. Okay. So what you will do if you are deleting the first node? So first you have to mark q is equal to start. What is yes? So yes, so yes is marked as start node. Okay. So no, q is equal to start node. So if it is a start node, what you will do? You will first make previous is equal to null. So keep in your mind, I am telling you again, that means you are deleting at the beginning. If you are deleting at the beginning, what you will mark? So s is equal to s then next, and s then next prev is equal to null. So this is the case that you will be taking if you are deleting, if your node is to be deleted. If it is last node, okay, q then next double equals null, this is the condition what you will be taking for last node. So if it is any intermediate, keep in your mind, here you are going with all the delete operations. So delete at the beginning, that we take it as first node. So here if the inserted is the last node, this is the question code. If you are going for any intermediate, so intermediate, this is the code. Okay. Q then prev then next is equal to q then next, and q then next then prev is equal to q then prev. So if you are removing, that means if you are removing any middle element, so then you have to go with the previous next. Okay. So middle element tegitidira. So what should be done? So node 1, node 2, node 3. Three cases, three nodes are there. Now you are removing only the one node. So if you are removing node 2, okay. So node 3, then node previous, then next should point to queue, then next. So and finally you are freeing one particular queue. Okay. So this is the delete operation. So deleting at the beginning, deleting at the end, and deleting at the middle. So this is the code you have to follow. Understood? So now you come for the main program. Okay, so seeing this, can you sort the elements? Okay, so first, can you sort the elements and tell what are all the last elements, what elements you have in your linked list? So first you see, first you will append. Append means already a list is there. For that you are adding the elements. So first element is 11. Node 1 is equal to, so I will give it here. Node 1 is equal to 11 and node 2 is 2 and node 3 is 14 and node 4 is 17. Node 5 is 99. Now I am going for a display operation. So if I going for a display operation, what I will get? That is 11, next you get 12, 2, and next you get 14, next you get 17, and finally 99. Okay, so total number of elements in the DLL. So how many elements are there in our DLL now? So it is 1, 2, 3, 4, 5. So total number of elements is 5. So now you are going for adding at the beginning. So adding at the beginning, now you see, so you are adding 33 and 55. Okay. So first you have added 33. So what are all the enter cases? So first one is 33, next you get 11, next you get 2, next you get 14, next you get 17 and 99. So for that, now you are going to add 55. So 55, next you get 33, next you get 11, next you get 2, next 14, next 17, next 99. So now you are going for a display operation. So display, when you go for the display operation, so you will be getting the same thing. Okay. So display operation, you will get it as same values. So same values. So total elements now, total elements 1, 2, 3, 4, 5, 6, 7. So total elements are 7. So after that, now you are adding after. After means one particular location. If you are adding at one particular location, what you have to do, what is the location? It is number 4, and at location 2, you are after location 4, you are adding 66. After location 2, after at location 4, you add 66, and at location 2, you add 96. So what will be the case? So 7 elements are already there after location, after 4. That means you are starting with node 1, node 2, node 3, node 4. So now you see already 55 is the first element, 33, next you get 11, next you get 2. After 2, that means node 1, node 2, node 3, no, after node 4, you will be inserting 66. So after 66, it remains. After 2, what was there? That remains same. That is 14, 17. Next you get 99. So similarly, you are going with a after 2. That means after 55. That is first location. Next you are getting 33. After 33, you are inserting 96. After 96, that remains same. 11, 2, 66. Next you get 14, comma 17, comma 99. So now I go with a display operation. So for the display operation, now I have inserted, now you are taking the count. So count is 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 elements. Okay. So now you come for the delete operation. Delete ampersand p comma 55. Next you delete 2, next you delete 99. So once you delete 55, what you will get? So the contents. So once you delete, this will be the case. Now you delete what? 2. So see here, you are deleting the element 2. So if you are going with a deleting the element 2, what you will get? So you will get 33, next you get 96, next you get 11, comma, next off once you delete 2. So this will be the case. So after 2, so you will be placing 66. Okay, so now you are going for a delete of 99. So once you delete 99, so this will be the case. So now you are deleting this much elements. So finally you are going with a display operation. So this will be the, so total number of elements are 1 2 3 4 5 6. 6 elements will be there. Here 9 elements was there. From 9 elements you have gone with a delete of 3 elements. So 9 minus 3 you will be getting 6. Okay, so this is the doubly linked list program. So I'm telling you, this is the program on doubly linked list. So very, very important from exam point of view. Have you understood? Got the program? Have you everyone got understood this doubly linked list? So now you come for the next part. What was the university question which was asked? Okay, so demonstrate with a logic to insert a node, new node between two nodes. So insert a node. So whether now can you answer whether it is insertion at beginning or insertion at middle or insertion at the last? So which one it is? So which code you are going to write? Answer for this question. So insert, you have three cases: insert at beginning, insert at middle, insert at last. So this program will illustrate which one, which case. So insertion at the middle. Okay, so this is the exam question, university question which was asked. So if you are inserting at middle, how many pointers you require? If you are inserting at middle, how many pointers? So keep this one in your mind. How many pointers are to be modified? Can you answer? How many pointers we have in the doubly linked list? Sorry, pointers I am asking, not the fields. Fields are 3. So first field is previous pointer, second field is data, third field is next pointer. How many pointers are there? So 2 pointers. So 2 pointers are, which are the 2 pointers? Previous and next. Okay, so this was the exam question paper which was asked. So that is, you have to write the particular code. Okay, so the add the code, that is add after. Okay, so that is the university question which was asked in the exam. So this is up to deletion operation in doubly linked list. Okay, so in doubly linked list we have gone with a insertion and the deletion operation. Understood up to here? Use this attendance link. So I've already taken the attendance. So kindly fill this Google form. Only 51 are present. I want only 51 to be answered. Don't share any link in your WhatsApp. Okay. So I have already taken the screenshot of all the members. So only 51, those who are in the class, fill the attendance form. Okay, all these particular videos, I will be uploading it in your YouTube link. So you can, if you are subscribed, you will get the notification and you can answer there. Okay, so I will be ending this particular session here. So see you tomorrow in the next class. Thank you all.